In this lesson, we are going to have a look at exponents. The first example we're going to have a look at is any number to the power of 0, which will always be equal to 1. So an example of this, 1 to the power of 0 is going to be 1. 15 to the power of 0 is going to be equal to 1. 0.3 to the power of 0 is going to be equal to 1, and a half to the power of 0 will be equal to 1. So as you can see, as soon as the power is 0, we have an answer of 1, no matter what this base number might be. We are now going to have a look at why any number to the power of 0 will always give you an answer of 1. As we can see what I've written here, we've got 4 to the power of 2 divided by 4 to the power of 2. Because our bases are the same, we are actually able to minus those powers. And because we know that 4 to the power of 2 is equal to 16, and 4 to the power of 2 is equal to 16, and because these numbers are the same, whenever we divide a number by itself, we will always get an answer of 1. 4 to the power of 2 and 4 to the power of 2, as you can see, are the same number, so dividing them by themselves, you will always get an answer of 1. If we have another look at an example of 25 to the power of 3 divided by 25 to the power of 3, that will also give us an answer of 1, because even though we don't need to work out what 25 to the power of 3 is, because our bases are the same, we are able to minus our powers. So 25 to the power of 3 minus 3 equals 25 to the power of 0, and that will give us an answer of 1. In the same way that 4 to the power of 2 minus 2 will also give you an answer of 4 to the power of 0, which gives us an answer of 1. When we write 5 to the power of 1, that will give us an answer of 5. When we write 5 times 5, what we need to do in order to understand our exponents and our powers is write these individual numbers also to the power of 1. That will give us an answer of 5 to the power of 2. And the reason for this is that when our bases are the same, we are able to add our powers. So we take 1 and we plus 1, and the only reason we can do that is because our bases are the same. So in our answer, our base will stay the same, and we've now added our powers. So that 2 over there we get from adding our powers. If we have a look at 5 times 5 times 5, we need to again put those numbers to the power of 1, because as you can see here, that doesn't change the value of the number. Putting a number to the power of 1 means the same thing as writing your number without the power of 1. So that doesn't actually change the value of your number. So when we are now timesing and the bases are the same, we are able to add our powers. So in this example, we've got 5 to the power of 1 plus 1 plus 1. And that gives us an answer of 5 to the power of 3. And so it goes on. If we've got 5 times 5 times 5 times 5 times 5, all we need to do is put or imagine that there are little ones, so 5 to the power of 1 in all these individual numbers, and we count how many there are. There are 5, so we end up getting 5 to the power of 5. We are now going to have a look at any number to the power of 1, which will always be equal to itself. Let's have a look at some examples. 5 to the power of 1 is always going to be equal to itself, which is 5. 27 to the power of 1 is going to be equal to 27. 0.75 to the power of 1 will always be equal to 0.75. 3/8 to the power of 1 will be equal to 3/8. So as soon as you've got an exponent of 1, your answer will be exactly what your original base number was. In this example, we've got any number to the power of 2, which is always going to be equal to that number times by itself. If we look at 6 to the power of 2, that will be equal to 6 times 6, which is equal to 36. If we have a look at 12 to the power of 2, that will be equal to 12 times 12, which is equal to 144. If we have a look at 0.2 to the power of 2, that will be equal to 0.2 times 0.2, which is equal to 0.04. If we have a look at 1/3 to the power of 2, that will be equal to 1/3 times 1/3, which is equal to 1 times 1 is 1, and 3 times 3 is 9. The answer to any number that we square is called a square number. So because 1 to the power of 2 is equal to 1 times 1, which is equal to 1, 1 is known as a square number. If we then go on to look at the first 5 square numbers, we will see 2 to the power of 2 is 2 times 2. 3 to the power of 2 is 3 times 3. 4 to the power of 2, 4 times 4. 5 to the power of 2 is 5 times 5. So our first square number is 1, because 1 times 1 is 1. Our second square number is 4, because 2 times 2 is 4. Our third square number is 9, because 3 times 3 is 9. Our fourth square number is 16, because 4 times 4 is 16. And our fifth square number is 25, because 5 times 5 is 25. So if in a test the question is list the first 5 square numbers, your answer will be 1, 4, 9, 16, and 25. We now have a look at any number to the power of 3, which means that you cube that number, which is that number times by itself and times by itself again. As an example, let's use 2 to the power of 3, which is equal to 2 times 2 times 2, which is equal to 2 times 2 is 4, and 4 times 2 is equal to 8. Then we have a look at 10 to the power of 3, which is equal to 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 is 1,000. Then have a look at 0.5 cubed, and that is equal to 0.5 times 0.5 times 0.5, and that will give you an answer of, well, 0.5 times 0.5 is 0.25, and 0.25 times 0.5 will give you an answer of 0.125. We then have a look at 1/3 cubed, which is equal to 1/3 times 1/3 times 1/3, and 1 over 3 times 1 over 3 is 1 over 9, and 1 over 9 times 1 over 3 will give you an answer of 1 over 27. When we cube any number, or when we put any number to the power of 3, we times that number by itself and then by itself again, and that will give us an answer of 1. 1 to the power of 3 is 1 times 1 times 1, and that will give us an answer of 1, and 1 is therefore known as a cube number. So if we have a look at the first 5 cube numbers, we will see that 2 to the power of 3 is 2 times 2 times 2. 3 to the power of 3 is 3 times 3 times 3. 4 to the power of 3 is 4 times 4 times 4. 5 to the power of 3 is 5 times 5 times 5. Our first cube number is going to be 1, because 1 times 1 times 1 is 1. Our second cube number is going to be equal to 8, because 2 times 2 is 4, and 4 times 2 is 8. Our third cube number is going to be equal to 27, because 3 times 3 is 9, and 9 times 3 is 27. Our fourth cube number is equal to 64, because 4 times 4 is 16, and 16 times 4 is 64. Our fifth cube number is equal to 125, because 5 times 5 is 25, and 25 times 5 is 125. So if in a test the question is what are your first 5 cube numbers, your answer will be 1, then 8, 27, 64, and 125.